Evaluate the triple integral. When you evaluate a triple integral, you're gonna want to do the same thing as how you would do a double integral, but you just add one more integral. So you want to separate it. This is gonna be 0. Separate this, the inner integral, and then evaluate this. So when you evaluate an integral in respect to x, you treat everything else as a constant. So you would then have x, y, cosine z from the boundaries pi to 0, which if you do the boundaries, plug in the boundaries, you would then have pi x, y, no. You would substitute pi for x, so you have pi y cosine z minus 0 times y cosine z, and this would cancel out. You're left with pi y cosine z. Now, moving on to this one. dy. When evaluating this, you can take out the pi, so you are left with pi times the integral from boundary 0 to pi y cosine z dy dz. And this, the integral of y cosine z in respect to y will give you y squared cosine z over 2 from the boundaries pi to 0. Therefore, if you erase these to make more space, you're left with y squared cosine z over 2 with the boundaries pi and 0. This will then be pi squared cosine z over 2 minus, and then 0 times anything is 0, so that cancels out. You're left with this times pi. Okay, so if you distribute the pi, you'll then have pi 3 cosine z over 2. And you want to find the integral from 0 to 1 dz. Okay. Now, you can take out pi cubed over 2. You will then have pi cubed over 2, integral from 1 to 2, cosine z. This is a 2, by the way, dz. The integral of cosine is sine, therefore you have pi cubed over 2 sine z from the boundaries 0 to 1. Now, if you evaluate sine z with the boundary 0 to 1, you are then going to have sine 1 minus sine 0 times pi cubed over 2. So if you evaluate it, sine 0 is going to equal to 0, so this cancels out. You're left with pi cubed over 2 sine 1. Let me rewrite it. Pi cubed over 2 sine 1. This will be your answer.